Problem number 3. So now we're going to evaluate some expressions. We see some square roots, so that should get us thinking, we probably need trig substitution to do these. So let's go ahead and get started on that. So a is the integral dx over x squared times x squared minus, or 7 minus x squared. So here we see its square root a squared minus b squared. You might say, well, 7's not a square, but it is. It's the square of the square root of 7. So your square doesn't always have to be nice. So let x be equal to square root 7. And because it's a squared minus x squared, we pick sine of x. So that's just something you have to know and be comfortable with. I gave you the rules in section 7.3. So that would be a good place to look if you're ever confused. But that's how we pick that. So then dx is the square root of 7 cosine, except not sine of x, sine of theta. Square root of 7 cosine of theta d theta. In which case this becomes square root of 7 cosine theta d theta over x squared is going to be 7 sine squared of theta. And then we're going to have the square root of 7 minus, same thing, 7 sine squared of theta. All of this is under the square root here. Okay. So now, first I can pull out a root 7 and a 7. Integral cosine theta, don't change anything there. Sine squared of theta, I can pull a root 7 out, because you're allowed to do that with square roots. If I have square root of a times b, that's square root of a times square root of b. So factor out a 7, pull it out. And then we have square root of 1 minus sine squared theta. And this is the whole reason that we do this weird substitution that seems like it makes it harder. Is because now we can say 1 minus sine squared theta, that's cosine squared theta. And then we're just taking the square root of something squared, which we can do. So this becomes, I can pull the root 7 out in the denominator, integral cosine theta d theta, and then we get divided by sine squared of theta, and this is square root we showed cosine squared, so that just gives you a cosine theta. So those now cancel, and you're left with 1 over 7 integral d theta over sine squared of theta equals 1 over 7. And now you might be looking at this integral 1 over sine squared theta and getting a little bit scared. But it's really not as scary as it looks. 1 over sine squared theta, that's the same thing as integral cosecant squared of theta d theta. We know that the integral of cosecant squared theta d theta from Cal 1, that this has to be 1/7 times minus cotan theta d theta. Okay, seems reasonable so far. But we're not done, because theta, we said, or rather we said x, was root 7 sine theta. So x over root 7 is sine theta, which implies theta is sine inverse x over root 7. So now we have, oops, this was not my first take of this problem. theta equals sine inverse of x over root 7. So we have this is equal to 1 over 7 with a minus sign in front, cotangent, and then theta is sine inverse of x over 7. And then let's add the plus c so we don't forget. Draw our triangle. Here's theta. Sine, oops, I wanted that. Sine of theta being x over root 7 says the opposite is x. And the hypotenuse, this is a root. The hypotenuse is the square root of 7. So this side is the square root of root 7 squared, also known as 7, minus x squared. You know you did the triangle right because whatever radical you get appeared in the original problem. That's a big bonus to doing this trig substitution. So root 7 minus x squared, that looks promising. And then we get that this is minus 1 over 7. And then cotangent, being 1 over tangent, is adjacent over opposite, which makes this root 7 minus x squared over x plus c. Okay, so that's part A. That's a pretty reasonable trig sub problem. Nothing too crazy going on. So I'm running out of space. B is another trig sub problem. So we integrate dy over y squared. This one looks really similar to the last one. Y squared minus 16. What's the difference? Here we had a squared minus x squared. Here we have x or y squared minus a squared. So what changes? Again, from the section, you pick y is equal to secant theta. You want whatever in front to square to give you 16, so you make it 4. Therefore, dy is 4 secant theta tan theta, because that's the derivative of secant theta. So this is going to be the integral. dy is 4 secant theta tan theta. Again, don't forget to write that dy. That trips up a lot of students, and they end up with a really hard integral that shouldn't be that difficult. D theta. And then y squared is going to be 16 secant squared theta times square root 16 secant squared theta minus 1. Again, the whole reason, minus 16. The whole reason we do this trig sub thing is because we can turn this now into, down in blue, we can make this 16 tan squared theta. Imagine factoring out a 16, pulling it out of the square root, stuff like that. And all of this is under the square root. So when we take a square root, we'll get 4 tan theta. Also, one of these secants cancels with both of these secants. Let me do that in pink. One of these secants cancels with one of those secants. So I'm left with 4. Let me pull the 4 out. A little bit of a mess. 4, so there's tan theta over 16 secant theta. And then we said we're taking the square root of 16 tan squared. So that's 4 times tangent of theta. Get rid of those, except I needed a d theta there. Not the 4. I don't know how I'm going to extract this pink line. Okay. Just the tans. But we can also cancel this 4 over here with this 4. and we're left with 1 over 16 integral 1 over secant theta d theta. And again, this one you might look at and go, oh no, 1 over secant theta. But 1 over secant is also the same thing as just cosine of theta, right? Because secant is 1 over cosine, so flip that equation, cosine is 1 over secant. And now this is a great integral, equals minus 1/16, not minus, integral of cosine is positive sign, sine of theta plus c. Again, we said x was for secant theta, so theta is secant inverse x over 4. So drawing our triangle, we get opposite, well, secant is, let's be careful, secant is hypotenuse over adjacent because it's 1 over cosine. So the hypotenuse is x, the adjacent is 4, so that means this side must be x squared minus 16. Doing great so far. So 1 over 16 sine, we said theta is 16 inverse x over 4. And so finally we get 1 over 16. Sine is opposite over hypotenuse. So the opposite is the square root x squared minus 16. And the hypotenuse is x. And then, as always, add on the plus c. And everything's looking good. So now let's do part C. So this one is the integral of x dx divided by square root 1 plus x squared. Okay, so this is the last case. We have a squared plus x squared. So I let x just be equal to tangent theta, in which case dx is secant squared of theta d theta. And so this integral becomes tan of theta d theta divided by square root 1 plus secant squared of theta, tangent squared of theta. Yeah, I wrote these completely backwards. Sorry. This is secant squared of theta d theta. Right. X is tangent theta times tan of theta because there's an x. Got it. X for the tangent theta, dx for the secant squared of theta d theta, and then x squared becomes tangent squared. So what happens here? We're left with secant squared of theta times tan of theta over the square root of 1 plus tangent theta. But again, the whole reason we do this, 1 plus tangent theta, is secant squared of theta. And so this is really just secant theta. So secant cancels with the squared there, d theta. So this is really integral secant theta tan theta. Look familiar? D theta. This is actually just secant of theta plus c. So these are generally the difficulty of trig integrations I would want, but be careful. You might see an integral where you have to use like a sine squared equals 1 minus cosine squared. A light integral like that, definitely nothing too crazy. But just a warning, the integral you get at the end might not quite be as easy as this, but it should be close. Not like some of the other stuff we've seen or some of the WebAssign stuff. But now we have to turn our attention back to theta because secant, this is secant of tan inverse of x, right? Because x is tan theta, so theta is tan inverse of x. So now let's do this. Theta. So tangent is opposite over adjacent, so that says the opposite is x. The adjacent is 1. So the hypotenuse is square root x squared plus 1. Again, hammering it home. You know you did the triangle right if the same square root that you started with shows back up. That's kind of the magic. So secant is 1 over cosine, so it's hypotenuse over adjacent. So the hypotenuse is the square root of x squared plus 1 over the adjacent, which is 1, and then plus c. Alright, so notice anything? We could have done a u substitution here and gotten the same thing. But it was good to do it this way, get some practice with trig sub. So not worth it to do it this way. And that's it for number 3.